All right, let's take a little trip back in time. I want you to think about your very first encounter with a computer. We're going to explore that feeling, that sense of wonder, by diving into the pages of an actual second grade textbook. So, you probably think you're pretty tech savvy, right? I mean, you spend your days coding or designing or just juggling a million different apps. You definitely know your way around a computer. But here's the real question. Are you smarter than a second grader? You heard me right. We got our hands on a computer science workbook for 7-year-olds, and we're going to put your expertise to the test. Let's see how we all learned the absolute basics, maybe not so long ago. Okay, first up, the fundamentals. Before we even knew about things like processors and RAM, a computer was, well, it was kind of like a magic machine. So, where did that magic actually come from? Here it is, the first rule, the absolute foundation of this entire world. What do you call a machine that works on electricity? You guessed it, an electronic machine. Super simple, right? But it's the key. It's not magic, folks. It's electricity. All right, let's get into the quiz. First question from the workbook. Let's see how you do. True or false, a computer can run a marathon? Come on, I have a feeling you know this one. Of course, it's false. A computer can't exactly lace up its running shoes. But look at what the book immediately points out. What it can do? Solve math problems. So it can't move its own body, but it can make numbers fly in a way that feels like a total superpower. Okay, next question. And this one really gets to the heart of what makes a computer so different from us. Can a computer get tired? Is it A, yes, or B, no? And the answer is a big fat no. A computer does not get tired. It doesn't need a nap. It doesn't need a coffee break. For a 7-year-old, that's incredible. This tireless, relentless quality is one of the first things we learned about them. And this chart just lays it all out perfectly, doesn't it? Humans versus computers. We make mistakes. It doesn't. We get tired. It never does. We work slower. It works way, way faster. This is such a brilliant, simple way to show the basic trade-off. Computers are our tireless, super precise, and incredibly speedy assistants. Okay, so now that we've established what a computer is, let's take a look at its body parts. It's time for the anatomy of a personal computer, the PC. You know, every team needs a leader, a command center, and for the computer, that's the CPU, the central processing unit. But let's be honest, the book gives it a way better name, the brain. And what does it do? It makes all the other parts work together. It's simple, it's memorable, and it's actually spot on. So how do you explain a monitor to a kid who's maybe never seen one? Well, the analogy is just perfect. You say, it looks like a TV. And just like that, it becomes the face of the computer, showing us all the words and pictures that are happening inside that magic box. You see where this is going, right? If the CPU is the brain and the monitor is the face, then the keyboard, well, those have to be the hands. This is how we actually talk to the computer. And all those little buttons, they're just alphabet keys and number keys are basic tools for getting our thoughts inside the machine. And last but not least, we have the mouse. The textbook calls it the pointer, which is great. And its job is right there in the name. It helps us point, click, and drag. With this little guy, we can finally reach into the computer's world and actually move things around. So we've met the whole team, the brain, the face, the hands, and the pointer. Now for the really fun part. What can this machine actually do? Let's take a look at a computer's superpowers. And wow, this list is pretty impressive. Just look at this. It goes from fun stuff like playing games and watching movies to really serious work like maintaining bank accounts and booking tickets. It can even help make animated movies and help doctors keep track of patients. You know, for a second grader, this must have seemed like a machine that could do literally anything. And then you find these little gems hidden in the exercises. Check this out. A computer can be used for matching fingerprints. Whoa! Suddenly, it's not just for homework and games anymore. Now, it's a tool for detectives. How cool is that? This one little detail makes the computer seem even more powerful and exciting. But for all its amazing powers, at the end of the day, the computer is still just a machine. It can't act on its own. And that brings us to our final section, which brings us back to this fundamental truth. There's always a person, a ghost in the machine, who has to be in charge. And that all begins with the very first thing you do. How do you start a computer? This 4-step process is just beautifully nostalgic. First, switch on the power.
Then switch on the UPS. Remember those big, heavy boxes? Then the CPU tower. And finally, the monitor. It doesn't just spring to life. We have to be the ones to wake it up step by step.
So, after all that, what is the ultimate limitation? After listing all of its incredible abilities, the workbook asks one final crucial question. What can a computer not do? And the answer is self-decision. It can count, it can play, it can draw, but it cannot decide anything for itself.
And that, right there, brings us to our final thought. This simple truth, taught to 7-year-olds, was the clear dividing line between us and the machine. But now, look at the world around us. We have AI that learns, that adapts, that creates. So we have to ask ourselves, is that still true? Can a computer still not make a self-decision? Now that is something to think about.